Hi everybody, I wanted to do a problem from 2.1, so let's look at this one. Suppose that a company just purchased some new office equipment at a cost of $2,500 per machine. The company chooses to depreciate each machine using the straight line method over 5 years. This means that each piece of equipment will depreciate by $2,500 divided by 5, which is going to equal $500 per year. Let's go ahead and build a linear model that expresses the value v of each machine as a function of its age x. We'll want to know what the domain is. We'll graph the linear function. We'll find the value of each machine after 2 years. We'll interpret the slope, and then we'll answer when will the value of each machine be $500. So for part A, there's a few ways that we can do this. The most important thing to notice in this problem is that the statement that the company chooses to depreciate each machine using the straight line method over 5 years, and then this part right here is telling us the slope, and that since it's depreciating, that the slope is negative, or the line is decreasing. So for part A, what we can say is m is negative 500. And since the office equipment is purchased new, that's telling us that when x is 0, the cost is 2,500. And then that point is a y-intercept, and so since we have the equation of the line y equals mx plus b, which is in slope y-intercept form, and we have the slope and we have the y-intercept, we're essentially done. All we would need to do is notice that we're expressing it as v of x. So v of x, which is y, is going to equal negative 500 x plus 2,500. So that's one of the ways to do this problem. The other way is, and I just want to show you this other way because sometimes depending on what's given, we'll adjust how we approach this. So we're not always going to be given the slope. And so what we can do is realize that we are given that y-intercept. So we have 0, 2,500. And the other point that we'll have is just kind of looking at the numbers is for what, well, let me ask it this way. For what year is the value of the equipment going to be 0? So for what year is the value of the equipment going to be 0? If you play with this information here, you'll assess that this is going to be the ordered pair 5, 0. So in 5 years, the value of the equipment is 0. And so what I've done here was used information to come up with 2 ordered pairs. Once I have 2 ordered pairs, I can use the equation, the formula for slope to find the slope, and then again now I have my y-intercept, and so I can get the equation of my line. And so m is y2 minus y1 divided by 5 minus 0, x2 minus x1. And so that's going to give us our negative 500. And then again, our equation, or our linear function is v of x is negative 500 x plus 2,500. So hopefully you can see like how these methods are kind of similar. There's lots of ways we can do this, so please feel free to be creative with these coming up with these equations of the line. So for part B, we want to find the domain of the function, and we want to be careful because we already know that the domain of a linear line is all real numbers, but we're not talking about just any linear line. We're talking about this linear line related to the problem. So what we need to do is, even maybe this is the benefit of looking at it in terms of these ordered pairs. If it's going to be year 6, the value of the equipment is negative money. That doesn't have any meaning. And so that's alluding to the fact then that the domain and interval notation is 0 to 5. So the domain is just that closed interval because it makes sense if it's the first year and the value is 2,500, and it also makes sense when it's 5 years later because the value is 0. But at that 5.1 year, it's going to be a negative value, so it doesn't make sense in the context of the problem. So for part C, I'm going to just erase all this and start again. We're on part C. And so we had just found that v of x is negative 500x plus 2,500. And so we want to graph that line. We're just going to stay in quadrant 1. The x is going to be from 0 to 5. And then 1, this is representing years. The y-axis is value. And so this is going to start off at 2,500. And then they're going to go down by 2,000. By 500. Then 1,500. And I went the wrong way. 1,000. Let's see if I can squeeze it in. And then 500. Alright. So when it's 1, or when it's 0, it's 2,500. Let's use a different color. When it's 0, it's 2,500. When it's 1 year, it'll be 2,000. When it's 2 years, the value will be 1,500. When it's 3 years, the value is 1,000. When it's 4 years, the value is 500. When it's 5 years, the value is 0. And I do not connect all my dots, but assume that those went through the dots. Oh my god, that's kind of funny. Okay, that's a little better. So that's the equation of the line. Now, one thing to note with this is that the purpose and the reason why we graph is that all the points that are on this order, all the ordered pairs that are on this line are a solution to our equation. So the points that I made, the nice ones, the 4 and 500, those ones, we can just crunch the numbers and see that. But there's like points that are like right there that I don't quite know the numbers of just looking at the graph, but I can say with certainty that that point is going to satisfy this linear function. Meaning, when I plug in the number for x, and plug it in here, do the math, get the value, that's going to be the y value here. And so when you look at part D, it's asking what is the value of each machine after 2 years. We can already just go to the graph and be like, oh, at 2, it's going to be 1,500. So for part D, you can just look at your graph. And we can say v of 2 equals 1,500. So the value of the machine after 2 years is 1,500. In part E, and also what we could have done too, right, is literally go on v of 2 is negative 500 times 2 plus 2,500. And we would have gotten the same answer of 1,500. Now for part E, we want to interpret the slope. And whenever I interpret the slope, I think about this is, I know my m is the change of y divided by the change of x. And you can even get it more specific to our problem. It's the change in value to the change in years. And we know that this is negative 500. So what I could say is the value of the machine of the equipment decreases by $500 each year. So notice as well, when I interpreted the slope, the word decrease takes into account the negative. So I'm going to use the word to replace the sign. And when you're in calculus, you're going to be interpreting the rate of change. So this part doesn't really go away. Alright, so we have part F. Maybe I'll just squeeze it in up here. And it's going to be again helpful to look at the graph. When will the value of each machine be $500? And so in using function notation, what we're asking is, what is x if v of x equals 500? So the v of x is here. This is our value. And so we want to know what is x. And that's going to be when x is 4. So you also could have replaced v of x with 4 here and just solved for x. But it's sometimes more convenient to use the graph. On these problems, you know, I don't really care how you get the answer. And so, like graphically, it's a great way to do that, especially if the problem had you graph it before. Like use that tool to your advantage. Alright, so sorry this is a long video. Hope you found it helpful, and I'll see you in the next one. Bye, class!